Okay, this is the second part of 4.4 lecture. We're going to solve word problems using systems of equations. So this is actually a really useful application sometimes if you need to determine certain things. So when word problems involve two unknown quantities, we create a system of equations to represent the problem, and then we can solve it algebraically. So for example, in a certain grocery store, candy bars and sodas are sold for a fixed price. That just means they sell them at a set price that doesn't change. Sally buys 2 candy bars and 1 soda for $4.05. Alex buys 3 candy bars and 2 sodas for $6.95. What's the price of a candy bar and the price of a soda? So first of all, it's important to say what variable is what. So let's call X the candy price. And let's call Y the soda price. It's always important you write that down so people know which one's which and which one you decide to be which. So now let's write our equation system. So for Sally, it says 2 candy bars. That means we have 2 times the price of a candy bar plus 1 soda. So plus 1 soda equals $4.05. And for Alex, we have that he buys 3 candy bars and 2 sodas for $6.95. So here's our system of equations. We have 2x plus y equals 4.05 and 3x plus 2y equals 695. Now, we could choose either method we want to solve this. I'm going to use the addition method because I want to use this example to show you something. So, step 1, we have 2x plus y equals 405. And I have 3x plus 2y equals 695. Now, say I want to eliminate my x variable. Well, there's no whole number I can multiply 2 by to get to 3. So, it's another thing of finding our least common multiple, or if we want them to cancel out, we can just say, what's 2 times 3? But since they're both positive, one of them needs to be negative. Anyway, I'm going to multiply the first equation, both sides, by 3. So when I do that, if I distribute, I'm going to end up with a 6x. So if I get a positive 6x in the first equation, and I'm going to use the addition method, that means I need to get a negative 6x in the second equation. And the way I do that is multiply by a negative 2. I know in the example in the previous video, we only had to multiply one equation by a number, but sometimes we have to multiply both equations. So, what does that get us? Well, when we distribute in the first equation, we get 6x plus 3y equals 1215. When I do the second equation, I get negative 6x minus 4y equals negative 1390. And now I'm going to add these two together. So there's my step 2. So when we add the two equations together, the 6x minus 6x goes away because that's 0. Negative 3 minus 4 is a negative y. And 1215 minus 1390 is negative 1.75. So, of course, we have to divide by -1 on both sides to get rid of the negatives. And we have y equals $1.75. So we now know that a soda costs $1.75. So let's go back and plug in into the other equation and figure out, well, either equation really, and figure out what the cost of a candy bar is. So I'm just going to use Sally's equation. So 2x plus y equals 405. And so I'm going to put $1.75 in for y, so plus 1.75 equals 4.05. So subtract $1.75 from both sides, and we get $2.30, and then we divide both sides by 2, and we get x, the cost of a candy bar, is $1.15. So what do we know? Candy costs $1.15, and a soda costs $1.75. Okay, we'll do, well, you should try to do number 7. Pause the video, and then you can pick up and see if you got it right. So, at a certain movie theater, regular adult tickets cost $10, and tickets for children ages 12 and under cost $8. For a particular showing of a movie, a total of 26 tickets were sold. The revenue collected during the show was $238. How many regular adult tickets and how many child tickets were sold? So we need adult tickets and child tickets. So those are going to be our variables. So let's say X is the number of adult tickets, and Y is the number of kids' tickets. Okay, so what are our two equations this time? We know the total number of tickets was 26. So that's the adult tickets plus the number of kids' tickets is 26 total tickets. We also know the total cost. And we know an adult ticket is $10. So 10 times X gives us the amount of money made by selling X adult tickets, plus 8 times Y is the total cost of the kids' tickets, has to equal a total revenue of $238. So this one we could solve by substitution if we wanted to. So let's do this one by substitution. So I am going to take X plus Y equals 26. and solve it for y by subtracting x from both sides. So that gives me y equals 26 minus x. Now I'm going to substitute in the second equation where y is. I'm going to change that to a 26 minus x. So we take 10x plus 8 times 26 minus x equals 238. And now we need to solve for x. So we have 10x, okay, and then plus 8 times 26 is 208. And 8 times a negative x gives us minus 8x equals 238. So combining like terms on the left-hand side, we have 10x minus 8x gives us a 2x plus 208 equals 238. And of course, subtract 208 from both sides. We get 2x equals 30. And dividing by 2, we get x equals 15. And x was the number of adult tickets. So we now know we had 15 adult tickets. And the last thing we needed to do was figure out how many kids tickets we have. So x plus y equals 26, but we know x is 15. So 15 plus y equals 26. And if we subtract 15 from both sides, we get the number of kids tickets is 11. So we have 15 adult tickets and 11 kids tickets. Okay, we will do another couple application problems in the next video.